Now, dear friends, welcome to everyone and good evening to everyone. Now, today I will be talking about the chi-square test. I hope all of you know the chi-square test, and there is one more which is known as goodness of fit test. What is the difference between them? The goodness of fit test can tell you whether your data are normally distributed or not, and the Colme Grove that I told you yesterday, that also can help whether your data are normally distributed or not. So you can use anyone you like. Now the assumption says one, there must be one or two discontinuous variable. So this is the one assumption. Shalini, you have to decide whether you want for dimension wise or you want total. If you want dimension wise, no problem. If you have 4 dimension, then you will have 4 variables. Each dimension will be considered a variable. And then you can enter your data in the data sheet and you can do whatever analysis you want. But chi-square is only for the tool where you have either 1 or 2 discontinuous variable or variables. Then the data are not normally distributed. Okay. And chi-square test is used to study the association, between 2 variables. You cannot take 3 variables in this. Only 2 variables at a time. That's all, between 2 discontinuous variables. So let us have one title. Title is A Study of Reaction Towards Online Teaching. A study of reaction towards online teaching of class 12 students of public schools of Baroda. Suppose this is my objective, then title, then my objective will be to study the association between gender and reaction towards online teaching of students. If you want, you can have another objective to study association between gender and reaction towards online teaching of students belonging to urban and rural areas separately. And if I have to write my hypothesis, one hypothesis will be there is no significant association between gender and reaction towards online teaching of students. The second will be there is no significant association between gender and reaction towards online teaching of students belonging to urban and rural areas separately. Now, let us take the data for the first objective and let us see how do we do the analysis. Now, do you want to write it 1 or do you want to write it, what was the last? Last was 4.6. Do you want me to write 4.7 or 4.1? What do you want? Do you want me to write 4.7 or 4.1? Okay, 4.7. So then it will be association between gender and reaction towards online teaching of students. And then I will say the 7th objective was to study. Now, here, can you name the variables? What are the variables from this objective which I have written here? Can you name the variables? No, Sukhraj, no. Jyoti, no. Shalini, no. Oman, no. Oh my God. Omani, now you have written reaction. This is not the complete name of the variable. No. Oh my God. Navita, your answer is correct. You are the only one who has given the correct answer. All other answers are wrong. Krishna, your answer is wrong. Because it is, you have written gender and reaction, comma, online teaching. This is wrong. My dear friend, here this is the one variable and this is the another variable. These are the two variables in this particular objective. Now you tell me, do you want the reaction towards online teaching a scale, a 3-point scale or 5-point scale? Which scale do you want? Is it 3-point or 5-point? All right. If you want 5 points, no problem. So let us go to the SPSS. So this is my SPSS. And I first go to the variable view. And here I am saying gender. And there are two levels of the gender. And one is called male. Male students. And two is called female students. Then another reaction, then dot towards dot, online dot, teaching. Now there are, you want 5. So let us say 1 means strongly agree. 2 means agree. 3 means undecided. 4 means disagree. And 5th means strongly disagree. Now, suppose you have the data of 100 subjects. So let me go to my data view and I say this is the data which I am entering of the gender, Oh, I have entered the data of, let me clear, I have the axis one. So I have 100. And now let us enter the data of the reaction. I have entered the data. Please make sure that you are entering the data from the records of your tool. One means strongly agree, and that I have already done it. No need for normality. That's right. Now I go to analyze. And if you see here, non-parametric, this is the chi-square. And in this chi-square, you only try to see whether your data are whether the responses of the people, they differ among themselves or not. So only the one variable you can take. You cannot take more than one variable in this particular one. And if you analyze Jyoti, I have already written one mix. You can see here I have written one mix strongly agree, two mix agree, three mix undecided, four mix disagree, and five mix strongly disagree. I hope you have understood it. So now in this chi-square, it is only the one variable. And you can find out whether your observation, your observable frequency differs from the expected frequency or not. If you are interested in studying the difference between the observed frequency and expected frequency, then you can use this. And if you use this, then here is your result. That there are 19 people in strongly agree, agree will be 30, undecided 19, disagree 15, and strongly disagree 17. And this chi-square is 6.800. And the degree of freedom is 4. And here significance is 0.147. That means the error is 14.7%. And the error should be either 5% or less than 5%. It is more than 5%. That means this chi-square is not significant. And if chi-square is not significant, that means your observed frequency do not differ from the expected frequencies. So this will be the finding over here. I hope you have understood that if you are interested in finding out whether the observed frequency and expected frequency differ significantly or not, then you can use this. What do you mean by it? Tell us the name. Goodness of fit. Goodness of fit test. So this is the goodness of fit test. But my objective is different. But if you have that as an objective, then you can do. If you want to now you want to study the gender, because there are males and there are females. Whether they are equal number or they differ. So you can just bring gender here, and then here is your output. So your males are 58 and females are 42, and the chi-square value is 2.56. And error is 11%, so it is not significant. That means males and females, their observed frequency do not differ significantly from the expected frequencies. If you are interested, you may even shift all the variables and can do analysis in one set. If there are 4 more variables, you can shift them and you can again do the analysis, you get everything. This is male and female. This is strongly agree, undecided, and the chi-square value. This is for the gender and this is for the reaction. So both the values are not significant. They are the same as you got it earlier. Now I want to study the association between gender and reaction. Then I cannot use the chi-square which is given in the non-parametric test. You see it very carefully. I go to the descriptive statistics. Please note down. I go to the descriptive statistics and then I go to cross tab. From descriptive statistics to cross tab, you click it here. Now there are 2 variables. One is the row, other is the column. So if you say gender is the row and column is this, perfectly correct. Now you can click on the statistics. Here is a chi-square. I hope you have understood it. So here is the chi-square. So I click it here. Do not worry, I will tell you. Now, this is your male and female. These are the people in the strongly agree, undecided, disagree, and strongly disagree. There were 58 males and 42 females. And here, the Pearson chi-square value is 0.303. And it is not significant because the error is 0.99. That means 99%. So that means this chi-square value is not significant. Okay. So let us copy this and make the table. My dear friends, some of you are asking me that if there are cells where the frequency is less than 5, so there must be at least 5 observation in each cell. If frequencies are less than 5, then Yates correction will be used by the SPSS. When you do your manually, then you know you use the Yates correction, where from each frequency you subtract 0.5. So it will be done automatically, nothing to worry. Then another is there should not be any empty cell. That means if there is a cell without observations, then you cannot compute chi-square. It's not possible. Navita, objective will be the same. Do not worry, I'm coming. I have the data. So I will now so these are the 2 more assumptions which you can write. Now, you know, this is my, so let us make that table. Table will be 4 point. I don't know what was the last table. Let me see. It was 4.5. So let it be 4.6. So let us have a table. So here I say gender. Gender is male, female. This is strongly agree. This is agree. This is undecided. This is disagree. And this is strongly disagree. This is total. This is total. So 10, 18, 11, 10, 18, 11, 10, 18, 11, 9, 10, and 58. Then the females are 9, 12, 8, 6, 7, 42. And then here are, it is 19, it is 30, it is 19, it is 15, it is 17, and it is 100. Yes, from the table of the SPSS, you cannot use it as it is. You have to make the table the way I'm making the table. So this is chi-square. This is chi-square value. And these two, if you, this you can delete if you so desire, because I cannot make that. So here there is a chi-square value, and the chi-square value is 0.30. So I can take out this, I don't need. And this is the reaction. So chi-square value for association. These are not percentage, these are the frequency. Sukhraj, these are not percentages. These are the frequency. by chance it is 100, it doesn't matter. So chi-square value of association between gender and reaction towards online teaching of students. Now, from table 4.6, it can be seen that the chi-square values chi-square value is 0.30, which is not significant. It indicates that there is no significant association between gender and reaction towards online teaching of students. Thus, the null hypothesis that there is no significant association between gender and reaction towards online program of is not rejected. So it may be said that both male and female students were found to have same type of reaction towards online teaching. And this becomes my finding. So if you copy, then this becomes the finding. So this is how you have to do it. I hope you have understood it. Is it clear? Have you understood or not? I am in the webinar. So I hope you have understood. Now, I have another objective, and let us see how do we do for that. The other objective is, this is my another objective. and it is 4.8.0. Now here, locale wise association, locale wise association between gender and reaction towards online teaching of students. Here the eighth objective was to study the association between gender and reaction towards online teaching of students belonging to urban and rural areas separately. Now, let me go to my SPSS. Now, this is my SPSS. Now, I have to add one more variable, and that is locale. It has got two levels. One is urban area. Two means rural area. So I must enter the information I've entered. Now, since I want to find out, study the association between gender and reaction towards online program of urban and rural area. So I go to the data and then select cases. So I should highlight now if condition is satisfied. And then I say if. Now I want to select on the basis of locale. Locale is equal to 1. That means now you will have the data of only the urban people. So you have the data of the urban people. Now let us do the analysis. We go to descriptive and we go to cross tab. And I have already entered and it is chi-square. I can go to the chi-square and let us say this is my. Now you can see here, there are some cells where frequency is 2, less than 5. here and here. So yet correction must have been used. And this is my chi-square value, and it is not significant because the value is 0.877. This is the error, 87.7% error. So I will take the data and I will tell you how to interpret. Interpretation is the same as I have done. Now, if I want the data of the rural people, then I again select cases and I come to the locale is equal to 2. Now I have the data only of the rural people and analyze descriptive cross tab, and this is my finding here. Now this is the value of the chi-square here. It is also not significant. So in none of the case it is significant. Now, so should I take both the and I interpret, or do you think you can do it yourself as I have done for the first one? Do you want me to interpret, or you can do it yourself? If you can do it yourself, then I take the another problem where the value is significant. So what do? Should I write, or you can write it yourself? I'm waiting for your response. Either you say you write, I will write, no problem. Okay, if you can do, fine. So let us now take another problem. Okay, and so I'm taking another problem, another data, and then let us see if the value is significant, then how do we proceed? Now suppose now I am taking the go to variable, and here I am taking locale, and I'm taking the one is urban students, 2 is the rural students. And another I'm taking, let us say, reaction towards online teaching. And here let us say I'm taking the 3. One I'm saying agree. Two I am saying undecided. And three I'm saying disagree. So let us enter the data. So you can enter some and then you can copy and paste. Suppose this is, I have done. Now I'm okay. Let us say one more because I have written so after. Suppose this is my data I have written. Sharma Saab, yet correction is inbuilt in the SPSS. And I told you that if you want to do with hand, then from the observed frequency, you have to subtract 0.5. Okay. So you have to use SPSS. SPSS does not show you the program, but it knows that if the frequency is less than 5, it will use. Nothing to worry about it. So now I go to analyze, I go to descriptive, and I go to cross tab. Now on the row, I'm taking locale. On the column, I'm taking the reaction. Now statistics, chi-square is already there. So I say, okay. Now this is my result. Oh, here the value is not significant. Okay, let me change some of the values and then maybe it will come out to be significant. I have to change some of the values. Let me see what is the situation now. Now the chi-square value will come out to be significant. Let me make some more changes. Now it is significant. Now it is significant. You can see that this is the chi-square value. It is 11.81 and it is significant at 0.01 level. DF is 2. So let us write say here I'm saying association between locale and reaction So the eighth objective was to study the association between locale and reaction towards online teaching of students. The data were analyzed with the help of here I did not write, my dear friends, see here the data were analyzed with the help of this was 2 by 5. Two by 5 contingency table, or you can say the chi-square with the help of chi-square test. You can write that also with the help of chi-square test. And the results are given in table 4.6. So now here I am writing the data were analyzed with the help of chi-square test and the results are given in table 4.7. association chi-square value chi-square value for association between locale and reaction towards online program or online teaching of students. Now this is my table. So let us take it on the next page. And here I can insert the table. So here is my locale. That means urban and rural. If you want, you can write here, urban and rural. Here it is agree, here it is undecided, here it is disagree, and this is my chi-square. Let us copy this sign from here. And then I can add one more column here. I'll say remark. Now here, it is 30, 22, 11. 30, 22, 11. Now next is 54, 10, 7. 54, 10, 7. Oh, 54, 10, and 7. 63, 71. And chi-square value is 11.81. And it is significant 0.1. Let me take out this also, I don't need it. Please do not forget to make the capital P as small p. Now, from table 4.7, it can be seen that the chi-square value is 11.80, which is significant at 0.01 level with df equal to 2. If you have to calculate the df, then the formula is column -1 into row -1. So here you have the 3 columns and you have the 2 rows. So this will be the 3 - 1 into 2 - 1. So that comes to 2. So this is how the chi-square, the degree of freedom is calculated in case of chi-square. So it indicates that there is a significant association between locale, there is an association between locale and reaction towards online teaching of students. Thus, the null hypothesis that there is no significant association, there is no significant association between locale and reaction towards online teaching of students is rejected. Now here, there must be a bracket here. Sukhra saying, I have given you the formula and your formula is not correct, because you have to say R-1 bracket, then bracket C minus. The meaning is very different of this. The meaning is R minus C minus 1, which is technically incorrect. I hope, Sukhraj, you are understanding what you have written. So you have written is R minus 1 into C. So that means 1 multiplied with C is C. So this is no wrong. So you have to have a bracket. So it may be said that locale and reaction towards online teaching of students were found to be significantly associated. So this becomes your interpretation if you have a significant value. Is it all right? Have you understood, or you want to ask any question? So the chi-square is very, very simple. There is no problem in that. So if you have understood, then I'm closing it here today. And tomorrow I will talk about Mann-Whitney U test, which you will be using in place of t-test if the assumptions of the t-test are not met. So those who are interested, you may read beforehand and come prepared tomorrow, and I will talk about the Mann-Whitney U test. No, there is nothing like post hoc test in it. Post hoc test will be in parametric statistics. After this, I will have 15 days webinar on basics of research. Another 15 days I will be having on parametric statistics. Then I will talk about post hoc test. So there is nothing like post hoc test here. So thank you very much. Keep learning. Stay safe. Thank you.